Quadratic equations. The Pythagorean theorem, we're going to do lesson 3. This is the last lesson in 7.6. Pythagorean theorem, I know you've worked with it before, so this is pretty much going to be a review for you. So the problems in your book will be word problems that you'll have to solve, but I'm going to show you in the video and just review with you. There are two situations that you're dealing with the Pythagorean theorem. Again, in the Pythagorean theorem, you just have a plain old triangle, and it's actually a right triangle that I have drawn here. And on the right triangles, in your right triangle, you have right angle like that marked. And so what we have to take a look at is how are these identified? Well, the parts that make up the right angle, that's labeled as A and B. And again, those are called the legs of the triangle. And then the long side is called the hypotenuse, and that's labeled C. The Pythagorean theorem then says that A squared plus B squared equals C squared. And I could go through a long explanation on how that was made, but the short story is if you take and draw a square off of the side A and a square off of side B and calculate their areas and add those two areas together, it will equal the area of a square drawn off of side C over here. So I'm not going to spend a lot of time with that. That's so I can keep this video shorter. So when I have a triangle like this first one here, so triangle 1, I have both legs are given to me. How do I know the legs? Well, the legs are always the sides that make up the right angle. And the right angle symbol always touches the legs. It always points at the hypotenuse. So I am missing the hypotenuse, or C here. So I would be writing 7 squared plus 5 squared equals C squared. And 7 squared being 49, and 5 squared being 25, and that equals C squared. And 49 plus 25 being 74 equals C squared. Now, one of the differences in what you've done in the past is now you've always, at this point, we just find the square root of 74. So we say the square root of 74 equals C. Now, in the past, you've either from this point, you've just found the decimal approximation, which we can do. But since you have been working with radicals, we're going to expect that you simplify this radical. And the first thing you want to ask yourself, are there any perfect squares within the square root of 74? No, there's not. So since there's no perfect squares within this, I will now just do the decimal approximation. So I'll get my calculator out, and it looks like I'm going to need the scientific calculator because I need my square root key. So I'm going to have 74, and I want to find the square root of that. So where is that rascal? It's the cubed root. I need the square root. So my square root, I'm going to press my square root key, and I'm going to tell them what the square root. So that means the square root of this is about 8.6. So back to my pen down here, and I say that this is 8.6 is approximately, and I use the wavy equal sign to say that this is an approximate. The answer is square root of 74 is the exact answer, because since the square root of 74 is an irrational number, as long as it's in radical form, it's considered exact. 8.6, that's an about or an estimate. So sometimes you're asked for one answer, and sometimes you are asked for both. So you need to know the difference between the two. So one situation that you work with is I have been given the measurements on both legs, and I have to find the hypotenuse. A lot of times in word problems, this is like a ladder problem. A ladder touches the floor 7 feet from the wall, and it touches on the wall 5 feet high. How long is the ladder? That would be one case, something that you might look at. Another thing they might talk about is if you are on a sidewalk, and I'm starting here at this point where the marker is, and I walk on the corner to the corner and then walk up to this point, how much farther is it to walk the square or walk the diagonal? How much farther is it to walk this square go over walking the diagonal? So you can then use a Pythagorean theorem on a problem like that. You'll probably see something like that in your assignment. So our second problem here then is, what if I know the hypotenuse, I know one leg, how do I find the other leg? Well, if I fill in, then I can just call this as A. I could also call it B also, but I'll just use A for now, because this is a leg. This right angle symbol is touching it. It was missing a measurement, so I'm going to say squared plus 6 squared equals 9 squared. So a squared plus 6 squared equals 9 squared. A squared plus 36 equals 81. Now, I can't add the two numbers, but what can I do? I can subtract them. So I will actually subtract it from both sides. So a squared equals, and then when I subtract, I get the square root of 45. Now at this point, I'm looking for perfect square factors in the square root of 45. There happens to be one. The square root of 45 is like the square root of 9 times the square root of 5. So I will say that a equals 3 times the square root of 5. That's my exact answer, and it's in simplified form. So now if I want the decimal approximation, if I'm asked for that, told round your answer like to the nearest tenth or nearest hundredth, then I'm going to take the calculator again, and I will then just clear out my calculator, and I'm going to do 3 times, and I need my square root of 5. Whoops, I got to do this again. Clear that out. So 3 times, and then I need my 5-foot square root. And notice I get then 6.7, so I'm going to come back here and say that A is about 6.7. Exact answers, if there's perfect square factors in them, you remove those and simplify it. So I'll call that my exact answer. When there aren't any, you write it like that, and then I can find my decimal approximation. So there'll be two types of calculations you're doing in the word problems. Sometimes you now keep in mind you'll be asked to, you have to remember to put maybe A back in and then do some other calculations. But this is what you need to get started with Pythagorean theorem word problems. One or two ways. You're either given the legs, got to find the hypotenuse, or given a hypotenuse and leg, and got to find the other leg. That's it for this video. Your assignment will be as follows, and I'll type that in here for you. We're going to do page, and we're going to be on page 456. And we're going to start with numbers, let's see here, whoops. Numbers 51, 53, 55, 57, 60, 61, oops, 61, let me get a comma in here, comma, 61 through 64, 69, 75, and 91. So please make sure that, as usual, that you show your work. And check your answers. Alrighty, I'll let you get to work on that. Let me know how I can help you.